All right, guys, so welcome back to Pope Does PLTW. In today's episode, what we're going to be doing is we are going to be creating what I call the aluminum Lego block part as a part of activity 8.2, which is parametric constraints. If you remember from our last video, we created a table for our constraints, and so we're going to create the part now based off of that particular table. In the screen where you can't see, I have open the table and also the instruction sheet because we need to look at the shape of the part, but we also need to look at the functions and the dimensions. So I'm going to start with the shape of the part, and it looks like it's going to be kind of a I don't know, I guess kind of a triangle pattern with some ends of it cut off. So the first thing I'm going to do in Inventor is I'm going to start a new 2D sketch, and I'm going to start it on XY, and I want to draw just the basic shape. And again, remember, I'm going to be starting this as an example, and then it's going to be up to you to finish the rest of the part for your submission. So I got my shape. Now I'm going to go back over to my chart, and the chart says D0 overall height, and this is important that you put this in as the first dimension because the rest of your parametric table is going to go off of this. Now at this point you should have your entire table filled out, even though I only did in the last screencast down to D11. So make sure you get your entire table filled out before you get this started. So we're going to go to the dimension tool. Overall height is 2 inches, so we're going to type in 2.0. And notice how it gets bigger, so we're going to get it back to the center of the screen. Next one is D1, which is the top width. And that, again, is a fixed dimension, so we're going to type in 0.5. All right. Moving on to D2, which is our right height. So our right height is going to be, according to our chart, now we're using a function, so D0 divided by 2 minus 0.25. And you'll know if you've done it correctly, again, it'll show up as an FX. And you can always check your table for the value that it should be. And the last thing we're going to do before we extrude is get our overall width. Our overall width is D0 times 1.5. Again, it says FX of 3. Make sure that you're checking your table after you enter each dimension. So that's the side of our part. And now we're ready to extrude. So we're going to finish our sketch. And we're going to extrude outward, not 1 inch, but we're going to follow D4. So we're going to type in D0 plus 0.25, and there is the overall depth of our part. Now, I mentioned in the last screencast that Inventor accounts for a depth taper, so I want to kind of show you what that's going to look like and how you can kind of check yourself. So you can go to Manage and then hit this FX button here, which is Parameters, and as you can see, just like I told you before, it enters in D5 here as a 0.0 degree taper. So I can go up here and I can always check what I have done. Now, the other thing that you can do to keep yourself on track is you can go into the comment tab and type in what the dimension actually is. So I can type in overall height. I can type in top width, and so on all the way down, so I can track with Inventor exactly where I'm at as your parts get more complex, and then hit done. All right, so we're going to continue now with our parts. Next one says upper hole diameter as well as lower hole diameter. So we're going to go back to a 2D sketch, and we're going to do it on this slanted face here. Now, Inventor brings this up as the top, but I'm going to rotate this around so that we get the right side. And for some reason, these little things are not popping up to rotate it 90 degrees. But you want your view kind of angled in such a way that you have basically the top showing over here and the right side showing over here. So again, for some reason on my computer, it doesn't want to necessarily bring that up, but I got it the best I can. So if we're going to do holes, we have to do points. So let's get 2 points. All right, and it doesn't really matter where they are at this point, but what does matter is that they are aligned, as we can see from the drawing. So I'm going to grab a line, and I'm going to put the line all the way through here, and I'm going to make it if I hit escape, go back over it, I want to make that a construction line because we don't actually want it to be an object line. Then I'm going to grab my coincident constraint, and I'm going to make sure that both points line up on the line. So that's it for right now. So I'm going to finish my sketch, and now I want to put in a hole. So the first one is going to be D6, an upper hole diameter. So right click, grab a hole, and my diameter is this guy right here. And on my chart, my function is going to be D1 plus 0.125. So there's my upper hole. Now, I want you to notice kind of what happens with your parametric chart after you do that. So go to Manage, Parameters. Now, notice it gives you, it skips around a little bit. So it gives you D11 as the hole depth, which we'll go back and change later, and D12 as a taper degree after D6. So really, I'm going to change my chart, and I'm going to note this on the side just so I can go back and know what is actually happening. So I'm going to go upper hole diameter, and I'm going to say upper hole depth, which we are going to change later on in the creation of this part. And then lastly, upper hole taper. Okay, so now I can go back and change my actual chart that I made earlier to reflect these. So upper hole diameter is still D6, but now we're going to have D11. So I go back, insert some rows, and I want to make my Excel chart match my parameter chart on Inventor. So I'm going to type in upper hole depth, and I make that D11. We don't have a function for that yet. And then my next one, I'm going to change this to D12, and this is going to be my upper hole taper, right? And that's just going to be a set 118 degrees. So that's not going to have a function. So I'm going to update that. All right, now I can hit done. So my next hole, my lower hole diameter, is actually going to be D13. So I'm going to change that on my chart. And then I'm going to show you the lower hole diameter in the next part of our screencast. Remember to like and subscribe to Pope Does PLTW, and we'll see you next time.